Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam. Good morning, sir.
Waalaikumsalam. Morning, sir.
Morning, sir.
Before we proceed with the exercise, okay, I want to continue with yesterday discussion first. Okay, first I would like to do some addition to the yesterday. Okay, let me show you this. So yesterday we already discussed about the three types of loop logic structure, right? Read this one. Okay. So the first type is while. Okay. While loop. Okay. Where we have the decision of the looping on top of the loop body. So this is the loop body. So on top of the loop body, we have the loop decision, right? Okay, so don't forget about this. If you want to apply looping, you must have these three elements. Okay, the first one is the initialization of the counter, and then the decision involving the counter, and lastly the counter update. Okay, the counter update. So why we need to apply looping? Okay, again, most of the time we apply looping for us to be able to do first counting, okay, and then second accumulating, kan? Okay, so this is while logic structure. So the difference with the do while or repeat until. So this is repeat until or do while is mainly on the position of the decision. Okay, position of the decision of the loop. For while it is on the top of the loop body, so this is the loop body. You can see the loop body from the flowchart much more clearly compared to the algorithm, right? In the flowchart, if you see there's a flow that some kind of uh, round over here, kan? A rounding flow, kan? So over here it goes here and then goes back up. So this is the loop body. So this is how we identify looping happen. So this is the body. Okay, all the process within the loop body can be repeated. Okay, so the position of a decision, okay, in do while is on the bottom of the loop body. So at the end, so this is the end process, the last process within the loop body. So at the bottom of the end process, we position the decision for the loop. So this is for do while. If for while, it is on top of the loop body over here. While. Do while or repeat until. So this is repeat until. Okay, repeat until structure. The position is on the bottom. Alright. So the three elements still presented. Okay, the first element, counter initialization, counter update, which is also the counting equation, and also the decision that also involving the counter. Right. Okay, so the third one is automatic loop, or we also call as a for loop. Okay, so for loop, all the three elements, okay, all the three elements that needed for a looping structure is placed inside of one symbol, okay, for the flowchart, okay, inside of the one symbol for the flowchart. So here we put the counter name. Okay, if you use counter as a name, you put here. Okay, if you use other variable, you put the variable name over here. Okay, replace the counter name. Okay, variable that is used for a counter. So this is the initialization of the counter. So let's say if you start the counter with 1, okay, as previously that we put in while and do while, you put 1. So it will start with 1, and how many times you want it to loop, you put the end over here. Okay, so this one is the incremental value. So if you want to the counter to be increment by 1, okay, the counting equation, counter equal to counter plus 1. So plus 1, you put 1 over here. If you want the counter to increment by 2, counter equal to counter plus 2, for example. So you put 2 over here. Alright. So this is where I forget to add one more thing. So this is for true, it will enter again. But actually there's no false over here for automatic loop. Okay, so there's no false over here. Okay, however, we change the structure. If false, it will do round. Okay, so this one. So what will happen is, if it is false, okay, if you can see from the algorithm is correct. So we place the decision, okay, all the three elements on the top of the loop body. So these are the loop body, and so this is the loop body. Okay, we place the three elements, the initialization, the counter update, and also the decision on top of the loop body. But on the bottom of the loop, so you should place this one, okay, the name of the counter that you use. Okay, in this case we use counter. Okay, so similarly for the flowchart, at the bottom of the loop body, okay, this one is the bottom of the loop body, kan, similar, right? So we have enter number, we have sum equal to sum plus number, we have enter number, we have sum equal to sum plus number. So this is the last process within the loop body. So at the end of the loop body, we place this statement. Okay, so similarly, at the end of the loop body, we place this statement. So you just put the name of the counter. Okay, if you use counter for the variable for counter, then we put counter. Okay, it should be a circle. Let me reduce this. Sekejap lagi masuk. Bangun tidur ke apa ni? Okay, alright, alright, alright. Ni kurang lah. Okay, circle. Okay, so this is in the case of the decision is false, it will continue over here. Okay, over here, not over here. Okay, it's supposed to be over here. Alright. This one I forget to add yesterday. Okay, macam ni. Ah, yeah. Okay. You see? Get it, class? Boleh?
Yes, sir.
Okay. So no true false lah. This one there's no true false for automatic. So if true, it will automatic. Sorry, called automatic. Automatic will do the looping. Okay, if false, it will continue with the false statement over here. Okay, right after the circle. Alright. So that's all. So we are going to continue with first the the apa benda the questions kan, the question. I will give you this one later, this file. What's the question? Kalam. Okay, so we have week 4 question. Okay, question number 2. Okay, the one that I asked you to submit. So this is very simple actually, but I think most of you got it wrong lah. I'm not sure what happened. This should be straightforward question kan. So from here you identify what are the inputs first, okay, and only one calculation kan over here, one simple calculation. So what are the inputs, class? How many inputs altogether?
3.
3.
3 input kan. Very straightforward. First is status, okay, whether married or single, and then husband income and wife income. That's all, right? Okay, so from here also, okay, so if you are required to develop the PAC kan, so make sure you copy this table kan. This table is very important because this is where the decision happen. This is where the decision. So how many sets of decision over here, class? How many sets of decision?
4.
4.
Set. Set of decision. First set is decision that determine whether the status is married or single. This is the first set. Kan? So 2 set lah. So the second set is to determine the discount kan, based on family income. So this is the second set. Okay, the second set. So the second set of decision actually reside inside of the first decision, the first set of decision. Okay, if the marriage status is true, kan? If the marriage status is true, and then inside of the true body of married, kan? If true, we do the family income decision set. So this is very important kan? This is why table is very important. If given a table like this, it is clear. If not, you have to construct your own table lah. Okay, to make you understand. Okay, so from here, okay, the flowchart should be full flowchart. Okay, some of you just take out this decision and do a flowchart without inputs, without output kan. So that is wrong, right? So you will lose marks over there. Okay, so let's do this together first. Then we are going to add looping to the system. Okay, alright. Okay, this is one of you. Okay, the answer of your friend over here, which is wrong, kan? So wrong in terms of input saya dah wrong, kan? So first input is correct. The second input is what? Income, what? Kan?
Wife income, husband income.
Yeah, it's supposed to be wife. Kan? Wife income and then husband income, kan? So let's do this from here, eh. So wife, boleh juga. Wife income. Salah pula buat baru lah. Okay, start. Then input. Okay, status is correct. So input status. Enter status. Okay. Then wife income. Okay, again, they are not. This is not the only answer, right? So you can also have the inputs within the decision. Okay, some of you putting the input inside of decision. Okay, so maybe it is also true. Okay, if you test it and then you get the same output, then meaning that your design is also correct, kan? Alright, and then what? Bagi soalan dia tadi. Okay, and then okay, if me, I prefer uh to group all the inputs together as long as it doesn't affect the flow of the process, kan? For me, I uh I like to do that kind of design, okay? So that later on, when we want to apply modules, okay, this is non-module, kan? Modules is we group all the similar process within one module, kan? So later on, kan, we will do that. Okay, and then as long as doesn't affect the process, the whole process, we can do this, kan? And then straight away, we do the calculation. What is the calculation? Income, eh? Family income, eh? Income equal to plus, right? Okay, and then we enter the main decision, right? So this is positive logic, kan? Positive logic is a normal logic that we already used previously, kan? Okay, it is the widely used design, okay, decision design that involving decision, okay, positive logic structure. So the first set of decision is involving the status, right? Status equal to the first one, merit. So if merit true, if merit equal to true, it will enter the second sets of decision. If merit is false, it will what? We do what? False. It will give the discount. Is it? Based on the family income. Okay, not eligible. So this one we can just put print F not eligible. Okay. Or discount not eligible. Doesn't matter lah. So as long as there is no eligible over there, kan? So let's say we just print not eligible. Okay, print not eligible. Lagi belum masuk ni. Okay. Mana saya punya tadi? Okay. Okay, so if this is for single, this is for married. So if this is true, then we entered the second sets of decision. Okay, if this is true, we enter the second set of decision. Okay, this one to determine the discount. So if family income is more than 5,000, less than 5,000. So just follow that one. Income, okay, family income lah I'm using income is less than, right? Is it? Less than or equal? Is it less than?
Less than, sir.
Less than less than 5,000. Sana sikit lah. Right, so if true, equal to 20%, 25%. So I put it 0.25, 25% ni Right, so this is true. So if false, it will enter the second conditions. So this is false. Ini true lah So you need to put true, false, true, false If it is false, it will enter the second decision of second sets. So altogether we need to have how many symbol for the second set How many decision symbol?
2.
Okay, right. So we have 3 decision to be made. So 3 minus by 1, maximum symbol that we can use is 2. Okay, so this one, the decision is family income more than or equal to 5,000 and less than 7,000. So you can do the range punya equation kan using n, or you can also use less than 7,000. So this is also the same meaning. Okay? Okay. So that if I'm putting only less than 7,000, so it is also correct. Okay? So less than 5,000 already covered by over here. So in between 5,000 and less than 7,000, so will be covered by this decision. See? Okay? Also correct. And if you want to use the and, also correct. But this is much more easier to convert later on. Okay? So if yes, then discount equal to 15%, right? 15%. So I put it like this. If false, discount is 0. Right? So if we already get all the discount, then we can proceed with there's no calculation, right? So we can proceed with printing the discount. Then and okay, and over here. So this one can go straight to N. Hmm. This one goes here kan tadi. Okay. Okay. Enter. Calculate. Okay. Enter the decision. Okay. Some of you want to do want to put enter wife income, husband income, and calculation. If status is married, you put it over here. Also can. Also you can do that. Okay. The flow is still similar. Okay. It won't affect the system at all. Doesn't matter kan. If you put everything, these three within this, okay, in between this decision, you put it, these three over here, also correct. Okay, play class. So this is positive logic structure. So if you require to convert this into negative kan, okay, if you are required to convert this into negative. So negative is vice versa. So this is if it is false, uh, Okay, if it is this is positive logic. If true, we give the correct value. With this one, if true, it will check. Okay, it will check the the next decision. So this is only applicable if we have more than one decision set lah. Sorry, if we have more than one decision in a set of decisions. Pening pula kan cakap ni. Okay, never mind. Okay, so let's look at the example. Okay, so this is the conversion table that you need to refer. Okay, so this is if positive using equal. So in negative, you should change it to not equal. Not equal to. Sekejap. If it is not equal to, you change it to equal. Okay, if it is less than, we change to more than to equal. Okay.
So the merit the status also we need to change to not equal for
Yes.
the negative.
Yes. If it is negative, then you need to change lah.
Okay, thank
Okay.
you, sir.
Okay. So this is negative. So this one we change to not equal to. Okay. So this is true kan. So this one should be true lah. Baru dia jadi negative kan. So if not married, then print not eligible kan. So the outcome is still similar. So if user entered status equal to single kan. So single is not married, right? So correct kan? Is it? Is it? Class. User entered single.
Betul ke?
So over here single. So true kan? True lah. So single is not equal to married. So true. So the outcome is still similar. However, we change the decision and also the flow lah. So previously it is equal to merit and this is false. Right now it is true, right? Okay, so if it is false, okay, if it is false, it will enter the second sets of decision, and this symbol is less than, kan? So less than we need to change to more than or equal to. So just apply the symbol, kan? So more than or equal to. Yeah? So this is false, should change to true, kan? So it is vice versa, kan? Vice versa, true. Right. However, the meaning is still the same. So this is false. So if false, then 25% discount. So similar. All right. So let's say if user enter income. So income, total income is 2,000. Okay. 2,000. False, right? So it will still give discount equal to 25%. Right? So it gives the same meaning, however, different structure. Okay, different structure of decision. So true. So originally less than. So we convert it to more. Okay, greater than. Okay, so greater than Okay, so more than 7,000. So it should be false. So the labeling is very important, true or false. So user know where to go. Okay, so this one is true lah. Okay, you see the one that I change is only on the part of true and false and also the symbols. Okay, the position of decision is still similar. Okay, I didn't touch the decision symbol kan. It's still there kan. Boleh kelas?
Boleh sir.
Boleh,
Alright.
sir.
Okay, so that's all. Okay, for algorithm, just follow the ni lah. Okay, the same thing. Okay, the same flow for algorithm kan. So next we are going to put, let's say you want to add a requirement. Okay, a requirement to this system. Okay, for example, you want this system to be able to repeat 3 times. Okay, 3 times user can enter status, wife income, husband income, and then it will give the discount total, discount how much, and then it will repeat again. Repeat again 3 times. You got it? You get what I mean, class? You want to repeat this
Yes.
system 3 times. Ini 1 time kan? So user enter status, wife income, husband income, and then it will get the discount. And then end. That's it. So now we want to repeat this 3 times. So what we need to do? Let's say the requirement is for you to use to apply uh, while loop. Tak muat je ni. Okay, apply while loop kan. So go back to our while general structure. While general structure must consist of 3 elements. Okay, counter equal to 1, decision, and counter update. So just take these 3 and put it in our design. So first counter equal to 1. Okay, on top of the design. Okay, put counter equal to 1 kan. Okay, counter initialization. Okay. Let me change this to different color. Macam mana color ni? Boleh. Of course there's an arrow lah. Lama malah nak pakai arrow ni. Detail. Kan, arrow. Okay, next is the decision. Okay, next is the decision. Muat. Ni adalah, okay. Okay, next is the decision for the loop. Okay. So we want it to be able to loop 3 times. So what should we put over here? Anybody? You want it to be able to loop 3 times.
While counter less than 4.
While counter less than 4. Rest of you, is it correct? Betul tak?
Yes.
Yes, betul.
Kan? So we start with 1, 1, 2, 3, 4. Wrong kan? 4 is false and then it will go out. Okay. So next is put true and false over here. So if it is false, it will go where? It will go out kan? It will go out. Okay. So this is the original end over here. Okay. So it will go to end. Long way down kan? Hilang pula dia. Go here. Okay, meaning that it will exit the loop If it is false, it will exit the loop. So what is the loop body? Everything within this, because we want to repeat everything starting with input and then calculation, decision and output. We want to repeat everything. So this is the loop body. Okay, so if we look over here, so this is the end. This is the last statement. Either this one or this one. So over here, we are going to put, what is the last statement within the loop? What is the last statement?
Update.
Huh?
Counter update.
Counter update. So this is the last statement within the loop body. Okay. So identify in the process, what is the last process? Okay, this is the last process. Down there, okay, at the end of the last process, we put counter update. Okay, the third element the third element, we put it in our design. Crowded sikit ni macam ni lah, faham lah Okay. So over here, we put counter update. And after that, we repeat again the whole process. Okay, so we must put arrow goes back to the decision. From here, it goes back up. Yeah. Alright. So where does the looping happen? Over here. Okay. This one. Okay, this is the last statement. Counter update. Then we'll repeat again. Okay, this is for false. Ish. This is if the decision is true. Bagi nampak sikit kan, overall kan. Okay, can you see this? So this is the decision. Okay, the second element. This is the third element. You know, I didn't change the anything within the original body kan. I just add these three elements. Okay, counter initialization, decision, and counter update. Okay, the rest is the same. Okay, the rest is same. Okay, I just put this 3 and then if false, it will go to N. Okay, so if it is true, it will enter the loop body. So this is the loop body. Okay, the one that we want to repeat, we put it inside of the body. The last element inside the loop body is the counter update, and then it will go up again and enter the decision. Okay, as long as the decision is correct, it will repeat again 3 times. Okay, any question, class? Simple, right? That's why I said that this is a template. Okay, if you want to apply it anywhere, you can. Any question? No?
No, sir.
Good.
No, sir.
Okay, so same goes to do while kan. So do while you just change the placement of the decision. Okay, put it below. Okay, so for counter, change this into the automatic symbol, and then you got it right lah. Okay, so I will enable quiz 2. Okay, right after the class, so you can start answering. I will open it until midnight. But please, this week is full with midterm test from many subjects and from all faculty So Kalam might be hard to access. Okay, during night. Usually lecturer will do the test during the night lah. So if possible, you can finish it before night lah, okay? Before 5 ke, before 7 ke, just take 20 minutes, okay? For the quiz to finish. It will cover until this part lah. Okay, while maybe some question on the decision, on the looping. Okay, the rest of the question mainly cover on the decision. And one more thing, okay, what I need to do, you need to do is, I want you to answer, okay, if you go to Kalam, okay, you don't have to submit it today, okay, week 6 lab question, okay, so due date for this is on Sunday, before midnight, okay, this is question, okay, question that I need you to answer is one question only. There's many question over here, right? So one question only, which is question number 3. Okay, please answer question number 3. Okay, this is the combination of looping and decision, and taken from previous final semester question. Okay, answer question number 3 only. Flowchart and algorithm. You may use any types of loop structure. Okay, while, do while, or automatic. Okay, whichever that you find easy to do. Boleh One question only. Question number 3. So submit before Sunday midnight. Boleh class? Any question?
Boleh.
Boleh.
Okay, kalau tak ada apa, okay, you may do this or you may answer the quiz. Right, so thank you and Assalamualaikum.
Waalaikumsalam.
Thank you, sir.
Waalaikumsalam.
Sir.
Thank you, sir.
Thank you, sir.
Salam, thank you,
Salam.
sir.
Thank you, sir.